Long division. Remember, long division always works. Remember back when you first learned long division, it was something like this. You had 243 divided by 5. And then you ask yourself, 5 goes into 24 how many times? 4 times. And then 4 times 5 is 20. And then I subtract and I get 4, bring down the 3. 5 goes into 43. 8 times 5 is 40. And then I subtract and I get 3. So my final answer ends up being 48, and you put the remainder, which is 3, over the divisor, which is 5, and that was your answer, 48 and 3/5. Well, when we do long division with polynomials, it's very similar. Notice that one of the things that we have to do is, as I made my big division line here, notice that I put 0x squared in there. If you have any missing terms, meaning the polynomial should be going down, 4, 3, 2. If you have something missing, you need to put that one in there with a 0. So notice that I put 0x squared in the middle there. Then my divisor here is 2x minus 3. And of course there should have been a parenthesis here and here. And so now I ask myself, just like we did in our long division a minute ago, 2x goes into 4x to the 4th how many times? 2x to the 3rd. But now, since the polynomial, you got to multiply this not just times the 2x, but times both things. So 2x cubed times 2x will give me 4x to the 4th. And then 2x cubed times negative 3 gives me negative 6x to the 3rd. Notice these are nicely lined up. That's why we want to make sure that if anything's missing that we put it in there, because then things will line up nicely. So I draw my line, and then remember what we're doing here. We're subtracting. But we're not just subtracting one thing, we're subtracting two things. So basically you've got to change the sign on both things. So I'm going to make this minus and this plus. So these two will cancel out, and I'm going to bring down 4x to the 3rd. And then I'm going to bring down the 0, x squared. And so 2x goes into 4x cubed how many times? It would be 2x squared. So 2x squared times 2x gives me the 4x cubed. And then 2x squared times negative 3 gives me negative 6x squared. When I draw my line, I remember I have to change the sign, so it's going to become minus and a plus. These cancel again. The 6x squared comes down. And then I'm going to bring down my negative 3x. So now 2x goes into 6x squared how many times? Positive 3x. So 3x times 2x gives me 6x squared. And then 3x times negative 3 gives me negative 9x. And then I remember to change the sign, so it's a minus and a plus. So these cancel again, and I'm left with 6x. And then I bring down the minus 9. And 2x goes into 6x plus 3 times. 3 times 2x is 6x. And 3 times negative 3 is minus 9. And then when I change my signs and subtract, I get a remainder of 0. Now it's always going to be true that your remainder is going to come out to be 0 if it is in fact a factor. And what we're going to really be finding here is we're going to be looking for the factors. So the first factor that we just divided was 2x minus 3. And then the second factor, which we got by division, is 2x cubed plus 2x squared plus 3x plus 3. Now we want to write this in completely factored form. So this is a 4 term. Could I factor it? Well, I think so. If I take a 2x squared out, I would end up with x plus 1. And then I can take out a positive 3 here, and I'd be left with x plus 1. So now I still have this 2x minus 3 in the front. And my common factor here was x plus 1. And then what's left is 2x squared plus 3. So when I ask you to put it in completely factored form, this would be the answer that you would be recording. You're going to factor it as far as you can factor it, and that first step is going to be division. And sometimes you might have to actually divide more than once in order to be able to get your factors. So now that I've got the factors, I can find my zeros. I just set each thing equal to 0. So I would get x equals 3 halves, x equals negative 1. And then this one doesn't come out too nicely because I end up with 2x squared equals negative 3. And then I divide by 2. And we suddenly have to remember these imaginary numbers, because when I take the square root of both, I'm going to end up with x equals I square root of 3 halves. And what did I forget to put in front of here? The plus or minus. So you have to also give me imaginary zeros. Just remember that when you put the I in front, that's the square root of negative 1. So it takes the negative that was underneath the square root sign away. So let's try another example. So I'm going to start by making my long division symbol. And I'm going to start with x to the 5th. And then notice that I don't have an x to the 4th. So remember to add that 0, x to the 4th. And then I have negative 3x cubed plus 8x squared. And then I don't have an x term, so I'm going to put plus 0x and then minus 24. Do the same thing with my divisor. I've got x squared, but I'm missing the x term, minus 3. Now again, this helps everything to line up nicely so that when I work it out, I'm going to get a nice lineup of questions so I can work it out. So x squared times what gives me x to the 5th? It would be x cubed, so I'm going to end up with x to the 5th. Then I have to multiply, so I'm going to get plus 0x to the 4th, and then minus 3x cubed. So I draw my line, and I subtract, change the sign on everything, and wow, everything cancels out. So I'm going to end up bringing this 8x squared down, and I need 3 terms to come down because I'm dividing by 3 terms here. So now x squared goes into 8x squared how many times? 8. So I get 8x squared. And then 8 times 0x is of course 0x. And 8 times negative 3 is negative 24. And so I notice that when I subtract, change the signs, I end up with no remainder. So my factors, now when I write the factors, I don't have to include all those zeros. So I'm going to put x squared minus 3. And then this one, I'm going to have to put x cubed plus 8. So now we have to remember how to factor a sum of cubes. So this one isn't a difference of squares, so I'm going to leave it as it is. Remember, it's a binomial times a trinomial. And you take the cubed root of x cubed, and you get x. The cubed root of 8, and you get 2, and you keep the sign. Then you multiply the first thing and square it. So you get x squared. Multiply the first times the second, and I get 2x, and change the sign. And then square the second thing, and I get 4. Now this one isn't real pretty. Now this would be my completely factored form because in fact if you remember with cubes that I can't factor this. If I multiply and get 4, there's no way I'm going to get something to come out to be a negative 2. So that's my completely factored form. But it's going to be a little more tricky with finding my zeros here. This one, when I set this equal to 0, I don't get imaginary this time. X squared equals 3. But I'm going to leave them as irrational answers. So it's going to be plus or minus the square root of 3. Then this one will be x equals negative 2. And then this one, I'm going to have to use that formula, quadratic formula. So remember, this is going to be x equals negative b, which will be 2, plus or minus the square root of negative 2 squared minus 4 times a times c all over 2 times a. And then when we simplify this, we keep the 2 plus or minus, and we just plug in what's underneath here. And we get a negative 12 over 2. And then remember, we're going to leave this as 2 plus or minus, and since it's negative, an I is going to come out in front. And then what can we simplify the square root of 12 to? It'll be 2 square roots of 3 divided by 2. And then all three of these terms have a factor of 2 in them. So we're going to divide by 2, and we end up with 1 plus or minus I square root of 3. So notice that we have 2 imaginary and 3 real answers for this particular polynomial.